400 or 400 RPM. There's the experimental FOPDT parameters. The average gain was is 17.3 with a variation of 0.2 RPMs per percent. The average dead time is 0.1 with a variation of 0.02 seconds. And average tau is 0.3 with a variation of plus or minus 0.2 seconds. Here's an example of one of our models for a set down from 30 to 5%, which is hard to see, but the light colored X's are the model, and we try to match as close as we could to our actual results from the other experiment. The model parameters were gain is 17.3 RPMs per percent. The dead time is 0.14 seconds, and the tau is 0.15 seconds. Here's an example of one of our sine responses with the frequency of 1 hertz. We are able to find the change in input, which is the M was 20. We measure that from the top of the peak to the valley right after it. Then T equals 1. You measure that from the peak on the output to the peak on input, I think. No, I forget. Then found the 3 different change in outputs to be able to find the rest of the information we needed. Here's our Bode diagram. From this, we were able to find the ultimate frequency of the Bode diagram was 4 cycles per second. I think it's 6 times. But then the gain, we were able to find the gain is 18 RPM per percent, and 1 over KCU is 3.1, which comes out to be, well, for this one, from my region, came out to be 0.4. KCU came out to be 0.4 or 0.2. Here's an example or a block diagram of a feedback control system and the closed loop transfer function. Here's the root locus parameters. The KCD is the highest value of KC that provides monotonic and stable output, which is critically damped. The quarter decay gain value of KC that produces 1/4 oscillating decay, and the ultimate gain, which is highest value of KC that causes oscillatory and stable output, marginally stable. The KCD is found where the roots go from real to complex. The quarter decay gain is found where the ratio of imaginary root to the real root is 4.5, and the ultimate gain is found where the real portion of the root goes from negative to positive. Here's our controller gains on the root locus. You can see the critical decay is at the tip where it crosses the x-axis, and the ultimate decay is at the top and the bottom where it crosses the y-axis, and the quarter decay is in the middle. And from this, we're also able to find the frequency of 43 radians per second. And with that, we're able to find the ultimate frequency of 6.8 cycles per second, which I'll talk about that later, compare all of them. Here's the results from root locus. The ultimate gain is 0.47. The quarter decay is 0.24. The critical decay is 0.05. And the underdamped is between 0.05 and 0.47. And it's overdamped if it's less than 0.05. Here's what I use for the proportional only model. Use a gain of 17.3, a dead time of 0.18, and a tau of 0.05 with a set point of 300 and a change in the set point. It's supposed to be 200, but I guess I accidentally put 100. Here's the procedure we use to analyze the graphs. You see the offset is from the blue line to the red line. The overshoot is from the blue line to the highest peak of the blue line, and then settling time and the change in the output. Here's the critically damped graph from the model. from my region 5 to 35%. We can see the decay ratio is 0 because it doesn't fluctuate and it doesn't oscillate. It's monotonic. It settles really quickly and has an offset of 54, but that's wrong. It's supposed to be at 107, I think. Here's the 1/500th decay. You can see it jumps a little bit right after the step, which it's oscillatory. Settling time fairly quickly, 0.3 seconds, and an offset of, I got that wrong too, I have to change these. It's supposed to be, I think 76. Here's the 1/10 gain, and the KC is 0.235 or 0.24 with a decay ratio of 0.3. It's oscillatory and settling time is 0.5 seconds, and an offset of, I think that's 20. That's right. Then here's the quarter decay gain. The gain is 0.311. Decay ratio is quarter decay, of course. Also, it's oscillatory and settling time of 5.5 seconds and offset of 16. Here's our ultimate gain. We know it's ultimate because it's steady oscillation. This is pretty much the same all the way down. The gain value is 0.74 with a decay ratio of 1 because it doesn't decrease over time, and it's oscillatory. And now for the experiment, here's what I use for the experiment. A length of 20 seconds, the bias of 18%, the set point of 300 RPMs, the changing set point is 200 RPMs, and the time of the step is 10 seconds. Here's the graph for critical decay. I found the gain to be 0.03, which is tricky because the smaller regions are almost all alike, so I had to zoom in and determine which one was best fit, so it's a ballpark estimate. It's monotonic and it has an offset of 130 RPMs. Here's the graph for the 1/500th decay. Found the value to be 0.06 with a decay ratio of 0.9 and a settling time of 0.25 seconds, and it has an offset of 97 RPMs. This is the 1/10th decay gain. Found that to be 0.08 with a decay ratio of almost a tenth. It's an oscillatory with settling time of 0.5 seconds. It has an offset of 83 RPMs. Okay, and on these graphs, since it never really settles down to complete straight line, so I just took the average of where it's steady state, and just found the decay ratio from that. This is the quarter decay, which I found that to be 0.1 because I found the ultimate gain first, and the equation is ultimate gain divided by 2. So it's 0.1, the decay ratio is 0.26. It's oscillatory, has a settling time of 1 second, and an offset of 70 RPMs. Now here's the ultimate gain. It peaks out at first and then settles out, and it's pretty much stays stable the rest of the way. So that's why I determined this to be the ultimate gain. The gain value is 0.2% per RPMs, and has a frequency of 2.875 cycles per second. This is a comparison of the ultimate frequencies from the Bode, the root locus, the ultimate KC model, and the ultimate KC experimental. They're all pretty much in the same same value, except for the root locus, and I don't understand why that one's a lot higher, but it is what it is. And yeah. And in conclusion, for the experiment, for the KC experimental, from my region 5 to 35%, I found the ultimate gain to be 0.2 percent per RPM. The quarter decay gain to be 0.1% per RPM. The